Hi friends, my name is Nandita. I am from Andhra Pradesh.
Good morning dear students. Today we are going to discuss about materials, metals and non-metals from Chapter 4, Class 8 CBSE syllabus. Children, you are familiar with a number of materials like iron, aluminium, copper, etc. Some materials have been given in table 4.1. Metals and non-metals combine with each other to form different types of bonds, while metal combine with non-metal to form an ionic bond. Non-metal combines with another non-metal to form a covalent bond. Metals are raised to have a low ionization energy and low electron affinities. Metals tend to lose electrons easily due to low electron affinity. On the other hand, non-metals have high ionization energy and high electron affinities and hence tend to gain electrons easily. Man's friendship with metals dates from prehistoric times. Initially, man became familiar with those metals which were occurring free in nature, like gold and copper. Gold was found at the time burial sites. Then man came across copper, and this was the first metal man started using extensively. This is the reason why this period was called the Copper Age. This was followed by the Bronze Age and the Iron Age. Children, there are more than 100 elements known today. On the basis of their general characteristics, they are broadly divided into two categories: metals and non-metals. There is yet another group of elements which show these characteristics of both metals and non-metals. Such elements are called metalloids. Among the total elements discovered, approximately 80% of them are metals and the remaining are either non-metals or metalloids. Children, let us see the position in the periodic table. In the periodic table, metals are placed on the left hand side and in the center, whereas non-metals are placed on the right hand side with the exception of hydrogen, which is placed with metals on the extreme left. The metalloids form a border diagonal line separating metals from non-metals as shown in the given diagram. Children, let us discuss in detail about metals and non-metals. All the elements around us categorized into three groups, that is metals, non-metals and metalloids. Thus we can say that all the elements in the periodic table are divided into these three categories. Metals and non-metals are two of the substances that may be distinguished by their physical and chemical characteristics. Metals are elements that are typically hard due to the presence of strong metallic connection between the atoms. Non-metals on the other hand are generally soft in nature. Children, first let us see what are metals. Metals are substances that are formed naturally below the surface of the earth. Most of the metals are lustrous, that is, they are shiny. Metals are made of substance that were never alive. This means that they are inorganic. They are natural compounds of the earth crust which are generally found in the form of metal ores. They are associated with each other and also with other elements. Metals are present in the rocks that are washed up by surface of water and groundwater. They also appear in the atmospheric dust. They are strong, ductile, malleable and good conductors of heat and electricity. Metals are used in the manufacturing of automobiles, satellites and cooking utensils among other things. The majority of metals are typically hard. Sodium and potassium are notable exceptions. Knives can be used to cut them. Most metals are solid except mercury, which is liquid metal at room temperature. Some common metals such as gold, silver and copper are shown in the image below. Children, let us discuss the common names of metals and symbol. Lithium symbol is Li, sodium Na, magnesium Mg, aluminium Al, potassium symbol is K, calcium symbol is Ca, vanadium symbol is V, chromium symbol is Cr, magnesium symbol is Mn, iron symbol is Fe, cobalt symbol is Co, nickel symbol is Ni, copper is Cu. Then come to the zinc symbol is Zn, gallium symbol is Ga, silver is Ag, tin symbol is Sn, barium symbol is Ba, platinum symbol is Pt, gold symbol is Au, mercury symbol is Hg, lead symbol is Pb, radium symbol is Ra, uranium symbol is U, tungsten symbol is W, thorium symbol is Th. These are the some of the metals common names and symbols. Children, let us discuss the physical properties of metals. Appearance. Metals usually have a silver or grey color except copper and gold. Copper has a reddish brown color whereas gold has a yellow color. Metals are widely used in our daily life for a large number of purposes. The cooking utensils, electric fans, sewing machines, cars, buses, trucks, trains, ships and aeroplanes are all made up of metals or mixtures of metals called alloys. In fact, the list of articles made of metals which we use in our daily life is unending. Physical state. Metals are solids at the room temperature. Generally, metals are very hard solids. All the metals like iron, copper, aluminium and silver and gold etc. are solids at the room temperature. Only one metal, mercury, is in liquid state at the room temperature, whereas gallium is a liquid at 330 degrees centigrade. Melting point and boiling point of metals. Children, metals generally have high melting points and boiling points. This means the most of the metals melt at vaporized at high temperatures. Iron is a very important metal. We used about 9 times more iron than all the other metals put together. Iron is made into steel and used for making large things like bridges as well as small things like needles. For example, iron is a metal having a high melting point of 1535 degrees centigrade. This means that solid iron melts and turns into liquid iron on heating to a high temperature of 1535 degrees centigrade. Copper metal has also a high melting point of 1083 degrees centigrade. Metals like sodium and potassium have low melting points. Another metal like gallium has such a low melting point that it starts melting in hand by heating our body also. Children, let us discuss the hardness of metals. Metals are generally hard. Most of the metals are hard, but all the metals are not equal hard. The hardness varies from metal to metal. Most of the metals like iron, copper, aluminium etc. are very hard and they cannot be cut with a knife. Children, let us discuss what is tensile strength. The ability to hold large weights without breaking is called tensile strength. Metals are hard and have high tensile strength. For example, iron metal in the form of steel is very strong, having a high tensile strength. Due to this, iron metal is used in the construction of bridges, buildings, railway lines, gliders, machines, vehicles and chains etc. Though most of the metals are strong, but some of the metals are not strong. For example, sodium and potassium metals are not strong. They have low tensile strength. Children, let us discuss the density of metals. Metals have high densities, which means that metals are heavy substance. For example, the density of iron metal is 7.8 grams by cm cube, which is quite high. There are, however, some metals like sodium and potassium metals have low densities. They are very light metals. Children, let us discuss the malleability of metals. Metals can be beaten into thin sheets with a hammer. This property of metals is called malleability. Gold and silver metals are some of the best malleable metals. Aluminium and copper metals are also highly malleable metals. All these metals can be beaten with a hammer to form very thin sheets called fossils. Example, silver metal can be hammered into thin silver fossils because of its high malleability. These silver fossils are used for decorating sweets. Similarly, aluminum metal is quite malleable, can be converted into thin sheets called aluminum fossils. Aluminum fossils are used for packing food items like biscuits, chocolates, medicines, cigarettes, etc. Milk bottles caps are also made up of aluminum foil. Aluminum sheets are used for making cooking utensils. Copper metals is also highly malleable. So copper sheets are used to make utensils and other containers. Thus malleability is an important characteristic property of metals. Children, let us discuss the ductility of metals. The capacity of a substance to be drawn into a wire is known as ductility. This property that permits metals to be used as cable wires and for soldering. All the metals are not equally ductile. Some are more ductile than others. Gold and silver are among the best ductile metals. For example, just 100 milligrams of highly ductile metal like silver can be drawn into a thin wire about 200 meters long. Copper and aluminum metals are also very ductile and can be drawn into thin wires which are used in electrical wiring. So we can say that metals are malleable and ductile. It is due to the properties of malleability and ductility that metals can be given different shapes to make various articles. Children, let us discuss what is sonorous. Metals are sonorous in nature. They produce a deep or ringing sound which, when struck with another hard object, this means the metals make a ring sound when we strike them. It is due to the property of sonorousness of metals that they are used for making bells, plate type music instruments like cymbals, and wires for stringed musical instruments such as violin, guitar, sitar, and tanpora, etc. Metals differ significantly from non-metals in many of physical and chemical properties. Let us study in detail of them. Children, let us discuss about lustrous. Most metals are lustrous in nature, means they have a shiny appearance. Metals are lustrous or shiny and can be polished. Gold, silver and copper are shiny metals and they can be polished. The property of metals having shining surface is called metallic luster, means chamak. The shiny appearance of metals makes them useful in making jewelry and decoration pieces. For example, gold and silver are used for making jewelry because they are bright and shiny. The shiny surface of the metals make them good reflectors of light. Silver metal is an excellent reflector of light. Children, let us discuss the heat and electrical conductivity of metal. Conductivity is the ability of a substance allows heat and electricity to pass through them easily. Metals are generally good conductors of heat. Silver metal is the best conductor of heat. It has the highest thermal conductivity. Copper and aluminum metals are also very good conductors of heat. The cooking utensils and water boilers, etc. are usually made of copper or aluminum metals because they are very good conductors of heat. The poorest conductor of heat among the metals is lead. Mercury metal is also a poor conductor of heat. Metals are the good conductor of electricity. Already we discussed that the metals offer a very little resistance to flow of electric current and hence show high electrical conductivity. The electric wires are made up of copper and aluminum metals because they are very good conductors of electricity. The metals like iron and mercury offer comparatively greater resistance to flow of current, so they have lower electrical conductivity. Solid. Metals are generally solid in nature except for mercury. All the metals are solid in nature. Children, let us discuss the chemical properties of metals. Metals have various chemical properties. Some of the properties of metals are listed below. Metals produce metal oxide when reacting with an oxygen in the air. Some metals like sodium and potassium are highly reactive and they cannot react vigorously with moisture in the air and are thus stored in an oil bottle. Metals are highly corrosive and they react with oxygen and water in the air to form rust. Metals react with bases to form salt and liberate hydrogen. Metals are good reducing agents also. Children, let us discuss the uses and applications of metals. Children, metals are usually very strong, durable, and highly immune to everyday wear and tear. As such, they need been used in past for tons of things. Even now, with developments in technology and a slew of other factors, metals applications have been expanded significantly. Metals are even important in economy. Let us see the uses of metals in construction industry. Metals are the most component within the housing industry. Iron and steel are amongst the most utilized metals in the construction of buildings and even homes. Electronics. Metals are utilized to make cables and parts of electrically powered devices and gadgets because they are good conductors of electricity. TVs, cell phones, refrigerators, irons, and computers are just a few examples of electronics. Let us see the uses of metals in medicine. Metal elements are required for a variety of functions including nerve impulses transmission, oxygen flow, and enzyme reaction, and so on. To treat a particular deficiencies or illness, several medicines are combined with metal compounds. Anticides contain metals such as iron, calcium, magnesium, potassium, titanium, and aluminium, which are commonly used in medicines. Children, let us see the uses of metals in automobiles and machinery. They are widely employed in the production of machines of industry, agricultural, and farming, as well as autos such as road vehicles, railways, aeroplanes, and rockets. Iron, aluminium, and steel are the most often used metals in these areas. The majority of cooking utensils are also constructed of metals such as steel, aluminium, and copper. Metals are performed because of their excellent thermal resistance. Children, let us discuss the other uses of metals. These days, most furniture is made of metals. Metals are also employed in the military where they are used in the production of weapons and ammunition. Galvanizing protects metals from rusting by using certain metals. Children, let us discuss about non-metals. Elements that lack the attributes of metals are called non-metals. Non-metals are good insulators of heat and electricity. They are mostly gaseous and liquids. Some non-metals are solid at room temperature. Example: carbon, sulfur, and phosphorus. Children, some common non-metals are shown in the image below. Let us study. List of common non-metals are hydrogen, state is gas and it's colorless. Nitrogen, state in the form of gas and it is also colorless. Oxygen, the state comes under the gas and colorless. Fluorine, state is gas and color comes under colorless. Chlorine, state comes under gas and greenish yellow color. Bromine, the state comes under liquid and color comes reddish brown color. Iodine, its solid state, it looks in grayish brown color. Carbon, it's in solid state and it looks in gray color. Phosphorus, it is in solid state and it looks waxy yellow color. Sulfur, solid state and it looks yellow color. Children, let us discuss the physical properties of nonmetals. The various physical properties of the nonmetals are: nonmetals are the poor conductors of heat and electricity. A notable exception is graphite, which is a good conductor of heat and electricity. Nonmetals are not ductile in nature except for the carbon, nanotube, which is ductile in nature. Non-metals are not malleable and they are brittle, that is, they break when hit a hammer or when force is applied. Non-metals are not lustrous as they do not have any shiny appearance. Non-metals do not produce a deep ringing sound when they are hit with another metal, thus they are not sonorous. Children, let us see the appearance of non-metals. Non-metals are dull in appearance and they are present in different colors. For example, sulfur is yellow, phosphorus is white or red, graphite is black, chlorine is yellowish green, bromine is red brown, whereas hydrogen and oxygen are colorless. Children, let us see the physical state of non-metals. Non-metals can exist in all the three types of physical states like solids, liquids and gases. For example, carbon, sulfur and phosphorus are solid in non-metals. Bromine is a liquid in non-metals, whereas hydrogen, oxygen, nitrogen and chlorine are gaseous non-metals. Diamond is a non-metal and it is the hardest substance known. Children, let us see the melting points of non-metals. Non-metals have comparatively low melting points and boiling points. This means that non-metals melt and evaporate at comparatively low temperatures. For example, sulfur is a non-metal having a low melting point of 119 degrees centigrade. The majority of non-metals have very low boiling points, due to which they exist as gases at room temperature. Only one non-metal, graphite, has a very high melting point, that is 3700 degrees centigrade. Children, let us see the hardness of non-metals. Non-metals are generally soft. Most of the solid non-metals are quite soft. They can be easily cut with a knife. For example, sulfur and phosphorus are solid non-metals which are quite soft and can be easily cut with a knife. Except only one non-metal, carbon, in the form of diamond is very hard. In fact, diamond, which is an allotropic form of carbon, is the hardest natural substance known. Tensile strength of non-metals. Non-metals are not strong. They have low tensile strength. This means that non-metals cannot hold large weights. For example, graphite is a non-metal which is not strong. It has a low tensile strength. When a large weight is placed on a graphite sheet, it breaks. Children, let us see the densities of non-metals. Non-metals have low densities. This means that non-metals are light substance. For example, sulfur is a solid non-metal having a low density of 2 grams by is quite low. The density of gaseous non-metal is very low. One non-metal, iodine, has a higher density compared to other non-metals. Malleability. Non-metals are not malleable and are brittle. This means that non-metals cannot be beaten into thin sheets with a hammer. Non-metals break into small pieces when hammered. For example, sulfur and phosphorus are solids non-metals which are not malleable. They cannot be beaten into thin sheets with a hammer. Thus, we cannot get thin sheets from non-metals like sulfur and phosphorus. When we beaten with a hammer, they break into small pieces. Brittleness is a characteristic property of solid non-metals. Children, let us discuss the ductility of non-metals. Non-metals are not ductile. This means that non-metals cannot be drawn into wires. They are easily snapped on stretching. For example, sulfur and phosphorus, and they are not ductile. When they stretch, sulfur and phosphorus break into pieces and do not form wires. Thus, we cannot get wires from non-metals. Lusterness. Non-metals are not lustrous or not shiny. They are dull in appearance. Non-metals do not have luster, which means that non-metals do not have a shining surface. The solid non-metals have a dull appearance. For example, sulfur and phosphorus are non-metals which have no luster, that is, they do not have a shining surface, they appear to be dull. Iodine is a non-metal having lustrous appearance. It has a shining surface like that of metals. Children, let us discuss the heat and electrical conductivity of nonmetals. Nonmetals are bad conductors of heat and electricity. This means that nonmetals do not allow heat and electricity to pass through them. For example, sulfur and phosphorus, which do not conduct heat or electricity. Many of nonmetals are in fact are insulators. A form of the carbon element diamond is a nonmetal which is a good conductor of heat, and the other form of carbon element graphite is a nonmetal which is a good conductor of electricity. Being a good conductor of electricity, graphite is used for making electrodes as that in dry cells. Sonority. Nonmetals are not sonorous. This means that solid nonmetals do not make a ringing sound when we strike them. Children, let us discuss the chemical properties of nonmetals. Nonmetals have various chemical properties. Some of the properties of nonmetals are listed below. Nonmetals are more reactive than metals. Nonmetals react with oxygen to form acidic oxide. Nonmetals react with other nonmetals at high temperatures. Children, let us discuss the uses and applications of nonmetals. You should be able to guess why metals are used in making machinery, automobiles, aeroplanes, trains, satellites, industrial gadgets, cooking utensils, water boilers, etc. You are so familiar with the uses of some nonmetals. There are here some interesting ones. We are sure that you will guess the right now. Nonmetals is essential for our life, which all the living beings inhale during breathing. Non-metal used in fertilizers to enhance the growth of plants. Non-metal used in water purification process. Non-metal used in the purple colored solution which is applied on wound as an antiseptic. Non-metal is used in crackers. You may add some more uses of non-metals also. Children, let us discuss various uses and applications of non-metals in our daily life. The respiration process is aided by oxygen, which is 21% by volume. It is also utilized to make steel and maintain a high temperature during the metal fabrication process. In the hospital, oxygen cylinders are used as a bleaching chemical. Chlorine is effective in eliminating stains and color patches. Chlorine is used to make a variety of polymers and pesticides. It aids with water filtration. Bacteria are killed when chlorine is added to drinking water. For scientific experiments, helium is employed as an intergas. Weather balloon use it as well. Iodine is used as an antiseptic in treatment of wounds and cuts as well as in the treatment of throat infections. Fertilizers. Nitrogen is found in fertilizers. It aids in the growth of plants. It boosts the plant growth rate. Plants can also benefit from non-metallic phosphorus. These two non-metals are essential for plant growth. Crackers. Sulfur and phosphorus are used in firecrackers. Children, let us discuss the difference between metals and non-metals. The study of metals and non-metals is very important in the study of chemistry. The basic difference between the metals and non-metals is discussed in the image below. Metals. Metals are solids at room temperature except for mercury, which is a liquid at room temperature. Non-metals. Non-metals exist in all three states, that is solid, liquid and gases. Then come to the metals. Metals are generally very hard except for sodium, potassium and mercury. And come to the non-metals are generally soft in nature except diamond and graphite, which are solid in nature. Metals are miserable and ductile in nature. Non-metals are brittle in nature and can break into pieces if struck by a hammer. Metals are electropositive in nature. Non-metals are electronegative in nature. Metals have high densities and non-metals have very low densities. Metals are lustrous in nature and non-metals are non-lustrous in nature. Children, metals and non-metals can be differentiated easily by knowing their physical properties like boiling point, melting point, ductility, malleability, thermal conductivity and chemical properties like electronegativities, etc. Oxidizing and reducing properties corrosion properties, etc. These distinguish features that help in differentiating metals and non-metals is metals like aluminium and copper is a high thermal and electrical conductivity, whereas non-metals like sulfur and phosphorus metals are the insulators. Some examples of metals including copper, silver, gold, platinum, aluminium, iron, nickel, etc. These are the examples of metals, and examples of non-metals are oxygen, nitrogen, potassium, sulfur, etc. Thank you.